Install System's Audio System Design Process. In this section, we shall demonstrate how to design a complete indoor simulated sound reinforcement system using DT Pro. Access the Install Systems mode of DT Pro from the Startup page. Import your prepared architectural model or the built-in practice model in the top right corner of the workspace. Assign materials to this model in the Surface Editor window. After completing the material assignment, proceed to the Audience Area Editing page. Add and configure spectator area properties based on the current building. It is recommended that the listening height within the audience area be set at the level of the audience's ears. After editing the audience area, proceed to the Source Editing window. Add sources from the source library to the project and edit attributes such as position and angle. Here we can activate the real-time direct sound simulation calculation for SPL. This enables us to synchronously optimize attributes such as the placement of sources based on real-time simulation results. Taking the auditorium simulation project here as an example, the auditorium comprises the seating area and the stage. If a point source sound reinforcement scheme is adopted, as such loudspeakers have a relatively short coverage distance, we may arrange multiple points at the front, middle, and rear of the audience area. To ensure that the sound pressure level and sound distribution in the audience area meet the required standards, if we adopt a line array sound reinforcement solution, these speakers provide extended coverage. We can install one line array system on each side at the front of the audience area as the main sound reinforcement system. Ensure sound coverage of the primary audience area. Additionally, install small-sized fill speakers in the front and backstage areas. It can evenly cover the entire field area. If the system requires a higher dynamic range, a sufficient number of subwoofers may also be placed in the front area. To boost low-frequency response, we can base our design on the audio system specifications for the corresponding region. Adjust the speaker position and angle accordingly. Ensure the system meets usage requirements. In addition to editing the basic position and angle, we can also access the virtual tuning module. Add a specified number of virtual devices here, and associate the speaker with the virtual device channel. Then we add a certain number of virtual receivers. Multiple receivers can typically be arranged according to the desired system optimization measures, based on the measurement data obtained by each receiver. Further optimization of the system can be achieved by adjusting the parameters of the virtual device. You may follow the debugging steps for the actual system. Perform system frequency response calibration, phase coupling, delay calibration, sound pressure level calibration, and full field adjustment in sequence. Parameters for virtual debugging will also simultaneously affect simulation results. By following the above steps, a more practical and effective implementation of the sound reinforcement system solution can be achieved. After achieving the desired direct sound performance through speaker positioning adjustments and virtual debugging, indoor sound reinforcement systems are influenced by architectural acoustics. We need to consider the overall sound pressure level of the sound reinforcement system, including reflected sound. Let's disable real-time direct sound processing. Obtain the total SPL indicator through manual calculation. After completing the simulation project configuration, proceed to the Report Export module. We only need to configure the project information related to Report Export. You can export a complete audio system simulation report. The report includes comprehensive project information, a summary of simulation results for the sound reinforcement system's performance metrics, the sound reinforcement system design proposal, and detailed data for each system metric. This completes the full design of the sound system. We can save this project for backup purposes. When the project is formally implemented, we just need to reopen the saved simulation project. Navigate to the Device Management module in DT Pro and search for the installed online devices, and quickly synchronize virtual devices parameters from simulation projects to online devices. The system pre-optimization can be completed immediately. Combined with the transfer function measurement built into DT Pro, optimize and adjust the system as necessary based on the actual on-site environment. That's it. The entire project, from design to implementation, is now complete. If you need detailed tutorials for each step, you may refer to the Simulation Software Functional Module tutorial for detailed usage steps of each feature.